rates of weathering. So natural weathering occurs very slowly. It can take 2,000 years, for example, to weather 1 centimeter of limestone. Most rocks weather at slower rates. Certain conditions, though, accelerate or slow the weathering process. So things like climate, the rock type and composition, the surface area of the rock, the topography or the shape of the land, all of these things can change our rate of weathering. So climate and chemical weathering. So climate is the major influence on the rate of weathering. So interaction between temperature and precipitation determines the rate of weathering in a region. Chemical weathering is rapid in climates with warm temperatures because, again, higher temperatures mean higher reaction rates, abundant rainfall, and lush vegetation. So this creates soils with high levels of organic matter. So heavy precipitation combines with carbon dioxide in the soil to produce carbonic acid, which accelerates the weathering process. Again, organic matter in the soil, you also get organic acids produced. Okay, so you get organic acids produced from this organic matter. The greatest effects really occur near the equator because you have high temperatures, you usually have high rainfall. And again, water is one of those key things that's involved in chemical weathering as well. So latitude and chemical weathering rates. So the red areas, you have the least effects of chemical weathering. Why? Because these are near the North Pole. These are cold areas. There's not a lot of rainfall. Areas like here on the west coast of South America, there's little rainfall as well. The greatest effects of chemical weathering are in yellow here. And again, these are areas that are close to the equator. There's high rainfall in these areas. So again, high temperatures and high amounts of precipitation increase our rates of chemical weathering. So climate and physical weathering. So physical weathering breaks down rocks more rapidly in cool climates, which is kind of the opposite really of chemical weathering. Because in chemical weathering, you have higher rates in warm climates. But physical weathering is faster in cool climates. This is fastest in areas with repeated freeze-thaw cycles. So again, one of our main things for physical weathering is this freeze-thaw cycle, basically freezing water, which then expands in the cracks of the rocks. Cold climates slow or inhibit chemical reactions. So chemical weathering is slower in these areas, but physical weathering is faster. So windy areas are also prone to more physical weathering because you have things like sand that are being blown around by the wind. And then when the sand particles hit rocks, it basically starts breaking off small pieces of the rocks, basically like sandblasting or even just sanding something with sandpaper. It's the same basic idea. So basically, this is a chart showing the relationship between rainfall and then temperature. So in these areas, you have these cold, dry areas. You could have these strong physical weathering events happening here because you have enough rainfall in some of these areas and it's cold enough. You have these repeated freeze-thaw cycles. You have more moderate weathering here as far as physical weathering. You get slight physical weathering in these areas, mainly because it's drier or it's warmer. You have very slight weathering of any kind really happening at these kind of hot, dry areas, except for the wind blowing sand around and things like that. These are desert areas. You have moderate chemical weathering with some frost action happening in these areas where you have a little more rainfall and higher temperatures. And then you have this very strong chemical weathering happening here. We have a lot of rainfall and higher temperatures. And then really these areas here, you really don't have areas on land where you have areas with this much rainfall and that match these temperatures. So this whole line right here kind of marks off an area on this graph that doesn't really occur on land. So rock type and composition. So different rock types weather at different rates. So rocks containing things like calcite, such as limestone and marble, weather more rapidly because they the limestones dissolved by things like acid precipitation or really just regular precipitation. Rocks containing mostly quartz, such as granite and quartzite, weather more slowly because quartz is kind of resistant to a lot of weathering. Surface area. So as mechanical weathering breaks down rocks into smaller pieces, the total surface area increases. More exposed surface basically means more places for weathering to occur. So this increases the surface area where chemical weathering can occur. And again, it's kind of like this. You have a big block of material here. You have a surface area of about 600 square centimeters. And this is basically 10 centimeters on a side, which means you have a face that is 100 square centimeters, and you have 6 faces. So 100 square centimeters times 6 is 600 square centimeters. If we break that down into pieces that are 1 centimeter each, well, each square here, each cube is going to have 6 square centimeters of surface area because you got 1 square centimeter on each side. But then you have 1,000 of these. Instead of one big block, you basically break that up into 1,000 little blocks. And then each one of those, all total then you got 6,000 square centimeters of surface area. So more surface area means there's more places in here that water can get in here and have chemical weathering occur, or the water to freeze and have physical weathering occur, etc. So more surface area means more chemical weathering. This also means there are multiple smaller pieces of rock will weather faster than one large block of rock. Okay, because again, you have all the space in here where the water can get in between the grains. Topography and weathering. So the slope of the landscape affects rates of weathering. So rocks on flat land tend to stay in place. Rocks on slopes tend to move downslope due to gravity, and this promotes erosion and exposes more rocks to chemical and physical weathering. So if the rocks break off, that exposes more surfaces. Also, those rocks breaking off are going to hit other rocks and break those rocks into other pieces, etc., as they fall down the slope. As the rocks move downslope, pieces tend to get broken off as rocks hit each other. Okay, so again, topography, if it's rocks on slopes, they're going to tend to weather faster because gravity is going to pull them down, break them into smaller pieces as they hit each other, etc.